Welcome to our live webinar event, taking design virtualization to the next level with X-Rite Pantone's Total Appearance Capture. My name's Greg Danino and I'll be your moderator for today's call. Before we begin, we have a few quick housekeeping measures. First off, to optimize your viewing experience, please disable all non-essential applications that might be running in the background on your computer, and when available, please use a wired internet connection for the best results. If you do experience any issues, start by refreshing your browser window, and if that doesn't work, close Adobe Connect's window and then log back in. If you continue to experience any type of technical difficulties during the presentation, please let us know through the Q&A box on your screen. Now, let's get on to our presentation. Our speakers today are Dr. Toby Rausch, Global Product Manager, Appearance Capture with X-Rite Pantone, Dr. Mark Ellens, Senior Research Scientist with X-Rite Pantone, and Mike Russell, Automotive Industry Business Line Manager with Autodesk. Toby and Mark will discuss how the Total Appearance Capture ecosystem works and how this new level of material scanning accuracy can help designers bring their ideas to life. Mike will talk about Total Appearance Capture's ability to transform the automotive industry's processes for designing products and creating marketing materials. At the conclusion of the webinar, Toby, Mark, and Mike will be available to answer questions about tax features and benefits. Please submit your questions during the webinar using the Q&A box on the left side of your screen. At this time, all participants are in a listen-only mode. Please note that this conference is also being recorded. I'll now turn the call over to our first speaker. Toby, you may begin.
Thanks a bunch, Greg, for the introduction. Welcome, everybody. Thank you for joining us today. I'm really excited to give you an update on X-Rite's latest technology in the next hour and how we take design virtualization to the next level. Today we are talking about an innovative solution to a problem we have identified by talking to industrial designers, visualization experts, and marketeers around the globe. There is a need for speed in design, especially when it comes to time to market. Consumer preferences are more demanding than ever before and changing faster and faster. Companies that can keep up will stand out in this increasingly competitive market. But this places an immense pressure on the shoulders of design and development teams. And traditionally, design has been a very manual process that still relies on estimations and the need to exchange physical prototypes with teams that might be scattered around the globe. One particular part of the process has been painfully slow, and that's the ability to virtualize materials used in the product. There have been improvements and innovations over time, such as CAD tools, the cloud, and the ability to develop rendering with 3D printing, where there's still the need to take accurate physical appearance characteristics and migrate them into the digital world. That's where our Total Appearance Capture solution comes in, also known as TAC. It's an innovation that speeds up the process of meeting consumer expectations across a variety of industries, and as I mentioned, we've developed it by talking with designers and the individuals involved in the supply chain. So we believe it's the last hurdle to fully digitize workflow and get products to market faster, so we're thrilled to reveal it here today. Let me give you a quick overview on the things we'll discuss today. First, we'll take a look at the current challenges in product design and simulation. After that, Mark will give you an inside view on our Total Appearance Capture solution. Next, Mike from Autodesk will lay out Autodesk's and TAC's ability to transform the automotive industry's processes for designing products and creating marketing materials. Finally, I will show you how this will positively impact your life, followed by the opportunity to raise questions and answers. So let's jump right into the presentation. On this slide, you see a generic value stream map for the product design workflow. This could be automotive, but also any other industry will face similar challenges. Typically, it starts with the material supplier. They have to maintain large physical sample libraries of their materials. Managing these libraries is quite complex as you have to add new materials and remove materials that are no longer available. Doing this for one location is already a complex job, but managing multiple locations or libraries at the customer is really quite painful. Besides this, making a material sample available for a designer takes some time. Mailing a sample from Europe to the US, for instance, takes a week before the designer can get his hands on the material. Besides, there are costs for producing the samples and for the logistics around that. By digitizing material appearance, managing a digital library becomes quite easy, and the information becomes instantly accessible from any design place in the world. For the designer, on the other hand, digital materials have the benefit that he can play with them in the CAD environment right away. Instead of looking at a small piece of fabric, he can see the material on his design visualization. To see how materials interact with each other, you don't have to build always an expensive physical prototype. You can already simulate the look and interaction of materials within a virtual prototype, which simulates accurately the real world. This also helps with the internal communication with other stakeholders like management, but also to give a feedback to the material supplier on changes and improvements of the material. In many industries, the marketing materials are generated in parallel to the product development. 3D artists quite often recreated materials for different tools and applications. The results often vary depending on the skills of the 3D artist and the complexity of the material. Quite often people waste a lot of time to create 3D materials in an artistic process and end up with different results in the configurator, the beauty shots, or the commercial. Last but not least, trends to bring virtual reality to the showroom call for digital materials as well. Accurate virtual materials will also help here to create the perfect product experience. Before I go deeper, we should talk about the material appearance really means. Especially working for a company with a long history in building color measurement devices, it's important to say that appearance is much more than just color or a picture. Appearance is the visual sensation through which an object is perceived to have attributes as color, gloss, texture, transparency, and translucency. Capturing these effects digitally was a challenge in the past, but that's not the case with total appearance capture anymore. Now digitization of the supply chain is as real and as accurate as possible. So let's have a look what really appearance means. Appearance is really the cross product of 5 things. The material with its physical and optical properties, the geometry, or in other words, the size and the shape of the object, the scene or environment which defines direct and indirect lighting, but also the surround, the spectral color of the lights and the proximity of the object to the walls and the light sources. Then there is the viewer or the camera who looks at the object from a certain angle and a distance. Last but not least, there is a lot of complex perceptual transforms going on in your perceptual system. Such transforms are contrast sensitivity, so it makes a difference if you look at an object under office lighting or bright daylight, tone mapping, chromatic adaptation, and of course the context. The orange part is what we want to capture with the TAC solutions. The geometry lives in the CAD wireframe, which is gray here, and the blue elements are taken care of in the rendering application. So here's a little bit more detail on the ecosystem we've developed for digital materials. First, we start to capture the materials with one of our total appearance capture scanners. This could be the TAC 7 instrument, for instance. Then the material has to be communicated through a software which is called the Pantora Digital Material Hub. We're using and leveraging the AXF Appearance Exchange format to talk to other applications, like the ones which we use for digital material visualization. That could be, for instance, Autodesk VRED, and Mike will show you a little bit more about this later on in the presentation, or it could be NVIDIA iRay. And there's many others implementing the AXF format right now. So now I'll hand over to Mark, and he will explain you a little bit more about the details of our TAC solutions. Mark.
Hello, everyone, and welcome. Thank you for joining us today. What we're showing here on the screen in this video as we start off is really at the end of the process. We're using this video to illustrate what we can do with our TAC initiative. This set of products ends with what we call the virtual light booth. In this virtual light booth, we have on the front side an actual light booth with the real material mounted on a rotation stage. In the back, we have a high brightness screen with a virtual material and a simulation that can be shown and demonstrates the capacity of the material scanner. So with that motivation, we're going to step back and look at the process in more depth. So how do we virtualize a material? First, we select a material that we want to construct a digital representation from. And we prepare this material, placing it inside the scanner in the TAC environment. Here we have a set of light sources and cameras that we can use to capture the material's information from all different angles, and then provide a way for that material, for that raw material, to be combined into a single representation. I'll show you in this next video how this process actually works in a physical way. Normally, most people don't get an opportunity to actually see what happens inside the scanner, but here you get a sneak peek of this. So after mounting the material inside the scanner, it moves in and up into the dome, and at which point the light sources and various cameras take multiple exposures, resulting in high dynamic range imagery. And in addition, we also put structured light sources so that we use the structured light source so that we can get the material surface information and produce a normal map. And then finally, we have a linear light scanner, which allows us to get and obtain high density gloss information. All of this gets combined into a single processing unit, which then produces an AXF file. This is what we see in step 3, is production of the AXF file. In that process, we use the Pantora software as our hub that we both manage the acquisition process as well as processing and then management of the materials. This format then can be produced and sent out to other rendering applications, which include our virtual light booth, which you saw at the beginning, as well as rendering applications, which Toby mentioned just a few minutes ago. After this, or during this process, we use this Pantora software, and here I'll show you a brief models, one being the car paint, which is a BTF hybrid, and an SVB RDF, which has various options associated with it. The processing of this then produces a resulting AXF file, which then can be put inside the browser and managed in a file-based system. And we also store properties that are associated with these AXF files so that they can be migrated into a customer's process in a very customized way. Once we've produced this AXF file, we can take a look at the different representations which are available, and also have high-level options for editing them to make a repeat out of them so that they can be used in a virtual environment. Once you're satisfied with how that works, we can apply it to our own objects. You can load your own objects or have an environment that actually manages the lighting for it, and this is the real-time OpenGL system. Then the final of that is the export or the transition to the rendering systems, one of which is Red, which we'll take a look at later. Some of the materials that we can actually process here are actually very complex, and so I'm going to show you a few samples of what we can do. You'll notice in this Alcantara sample that the soft subtleties of the edges come out very nicely, and this is typically a material that's very difficult to manage if you're going to do it by hand. As well as the pebbled leather, which if you look closely has varying gloss levels across it, as well as a very natural texture, which with our expert tools we can help produce a repeat that is not very noticeable. Another great example is this high gloss sample, which has both this high gloss feature, which varies across the sample, as well as natural breaks, which are not regular and difficult to maintain. Finally, a couple samples of things that work really well. The natural fabrics with repeat patterns, with fine threads, and also metallic paint with flop colors and high levels of sparkle. These are all samples of materials that can be very well done in the TAC system and allow us to actually enhance your visualization capabilities. So how does this process work? We've mentioned this a couple times already, but essentially the SVB-RDF that is produced by Pantora results in a bunch of texture maps, which are part of the representation. These are inputs into the SVB-RDF model, which can be then applied in a rendering system. We combine that with the CAD wireframe and the lighting information that we talked about earlier to produce a photorealistic rendering. And with that, I am going to turn it over to Mike Russell, who will talk to us a little bit more specifically about RED.
Thanks very much. It's a pleasure to be here and show the importance that Autodesk sees materials playing in design studios. Let's see if we go forward. There we go. Today, Autodesk supports the automotive industry with a multitude of different disciplines. However, today I want to talk to you about the design studio. For a while, Autodesk has been supporting automotive design studios with products like Alias and Maya, and for surface creation. Plus, a few years ago, we acquired a company called VRED, which has helped us to deliver on the Studio of the Future. VRED stands for Virtual Reality Editor and is the market leader in real-time ray trace visualization technology aimed squarely at the automotive industry. VRED's strengths are its speed, its accuracy, its scalability in creating these interactive scenes. Just to give you a quick idea, here's a video of VRED being used. In this scene, secondary interactions have been created to assist for something like a design review. However, you can see that the quality of the scene is very high, meaning that our customers can take decisions based on digital data rather than having to make a physical version. As you can imagine, the cost to take a car to market is very high, meaning that a single mistake can be costly. If you add into this the growing pressures on a design studio with increased throughput to release vehicles to serve new market segments and with faster turnarounds for updates, being able to create 100% digitally accurate data and base decisions on that data is critical. VRED can serve the complete visualization needs within the enterprise, from early concept design reviews through to collaborative design reviews. We support engineering teams with perceived quality, visual simulation for light analysis, and we can connect to marketing content creation like car configurators. Or to put it another way, a complete end-to-end solution with a single product. However, there's one very important part to be able to support this vision of end-to-end process, and that's by having a connected materials library. Often our customers lose time with working different materials databases, trying to make sure that the metallic red is the same across the whole process. As color and materials become ever more important in the perception of a product, making sure that consistent and accurate materials library that can be used throughout one complete visualization pipeline is critical, and this is where Autodesk sees the real benefit of working with X-Rite. This is a quick example of a scene that was scanned using a scanned material read directly into VRED using the AXF format. VRED has a direct integration to the X-Rite file format with no secondary work needed, allowing you to see your scanned material very quickly in your scene with no middleware required. Although this might be an odd scene with a car seat in a field, but it does highlight the quality of materials applied directly to the seat. It's this speed and the quality that's critical to a modern design studio. I'd now like to hand back to Toby.
All right, thanks a bunch. So what we just introduced today, this is really just the beginning. And so where we really are right now is the first layer, which you see down there at the bottom. So what we try to do right now is to try to capture appearance with our total appearance capture scanners like the TAC7. We try to communicate appearance with the AXF format, and we try to visualize it with the help, for instance, with Autodesk VRED. So this is where we are today, but we have more in mind with this kind of technology. So the next thing we're already working on is the possibility to edit appearance. So X-Rite is also, we also have a lot of software around formulation. So this is today something which only works with color, but this is something which will tomorrow also work with appearance data. The next thing is browsing databases and find appearance attributes in there. Just imagine finding a red car paint is quite easy because red is something we can translate into LAB values, but trying to find a red fluffy carpet, this is a little bit more complicated. And this is something we're working on to find also a red fluffy carpet in the library. Last but not least, we also have the Pantone system, which is quite popular to find colors. We also work on the Pantone naming system for appearance. And last but not least, in the future, we want to do something which is quite common with color today. So a lot of our instruments which we are producing are used to check the color quality of things which are going to be produced. So instruments from us are used, for instance, to check if the color of the dashboard is white. But what our customers really want is they also want to see if the appearance of the dashboard is correct. And this is where we want to go tomorrow. This is where we want to try to measure the difference of appearance between two dashboards. We want to try to compare things in the production process, and we want to try to differentiate things. So this is really what we're working on into the future. So stay tuned what we're going to develop there for the market in the next couple of years. So now the best part. What do you get out of it? The total appearance capture solution gives you realistic and accurate scanning through the creation of customized materials, as well as systematic appearance-based quality control. It also gives you better material capture with simplified maintenance of material libraries and simplified logistics for digital samples. All of that results in reduced time to market because you've got more accurately rendered marketing materials, time and cost savings because you'll have the ability to cost effectively explore different materials, reduced waste in production because you're minimizing the need to create physical samples, and improved marketing communications for your team and the customer with accurate renderings. Plus your e-commerce and showroom will be improved by true realism. So I know Jan Pflüger is also in the audience, but and he of course said something in German which we tried to translate into English. Core of our material processes is a flexible solution for easily creating, processing, and providing virtual materials in a multitude of different systems with the ultimate level of realistic deception. I'm pretty sure she didn't say that way. But solutions from our partner X-Rite help us to accomplish this task. I know it was much easier in German to read out. Then we have the next one, and that was a statement from Volkswagen. So Dr. Markus Denny, head of the Digital Image Factory, said, to turn the vision of a fully automated car configurator process into reality, TAC is essential. X-Rite's solution enables us to reach true-to-life quality images to replicate highlights in our car paint job. So as you can see, there's quite a few users already using our technology out there, and that's a great thing to see. So to summarize, where will this revolutionize life for designers? The Audi and Volkswagen are using the total appearance capture solution, but it isn't just for the automotive and transportation industry. Our research shows it could revolutionize design and help speed time to market in these areas as well. So automotive and transportation is just one thing. Architecture and building materials is something else. Media and entertainment is another segment we can look into. Textiles and fashion and home is another one. And of course, general industrial design. So To conclude, we can now receive some questions and answers, and I hand over to Greg to moderate the question and answer session again.
Thanks, Toby, Mark, and Mike for the presentation. It was very informative. Looks like we now have several minutes for questions from the audience. Our first question is, looks like for Mark, and then possibly Mike from Autodesk as well can share some information. How accurate is color in the virtual environment?
Hi, Greg. Yes, that's a good question. The color in the virtual environment, we actually, in the TAC scanner, we use these calibrated spectral filters to determine the color of the material. So the information that's actually stored in the AXF representation or in the raw data that we use is spectral in nature. The AXF file currently only supports RGB, or it's linear RGB, so it's non-gamut limited. But inside the virtual light booth, the calibrations are set up to handle this linear RGB within the high brightness environment of the actual light booth. So the color accuracy for the virtual environment and the display is extraordinarily high. What we have found, though, is that the person who's using the virtual light booth has sensitivities to color in various ways, and this depends person by person. So the perceptual characteristics of someone's visual system are really influential in that environment. And so we've done our best to basically hit the middle of that environment and produce the best experience for everyone. What you don't see is the extra effort that we put into the virtual light booth, which includes ambient light scanner, ambient light sensors, real-time color management, the angular dependency of the color profile on the back screen, as well as eye tracking and face tracking so that the view of the back can be done independently, or that can be coordinated with the viewer position. And so the color between the actual material and the back is extraordinarily high and better than any other evaluation environment that we've been able to see or produce. So I hope that answers the question there.
Great, thanks, Mark. Our next question for the audience, for Toby. What types of materials is TAC capable of capturing and communicating?
So, yeah, that's a tricky one because there's a lot of materials out there in the world. But in general, I can say that a lot of materials which have a distinguished surface can be scanned with the TAC scanner. So there's a few things which don't work very well. This is really if you have a material without the pattern repeat, because we're only capturing something like 13 centimeters in diameter. So if you have a natural material like wood or like marble, then you have a problem with the pattern repeat. So something like this is very difficult to scan because it will look like bathroom tiles at the end because you don't really get a seamless tiling with these kind of materials. The other things which are a little bit complicated for us is materials which are shadowing itself. So something like fur or hair, this is something which is complicated to measure because the cameras are not seeing what's going behind the first fibers. So these kind of materials are a problem for us in general. Then there are some things which are a little bit more difficult, like fluorescence or something like retroreflection, like number plates. So this is something the system is not seeing because there is no UV LEDs in there, and there's also a retroreflection. You would have to have a light source where the cameras are. So this is something we can't capture with the device. But besides that, a lot of things work, and it's really worth trying them. But so far, we really experienced that roughly 80% of the materials inside a car and outside a car work quite well with the system.
Great, thanks, Toby. We have one more question for you, Toby. Can customers purchase a TAC scanner, or are the scans done on the site at X-Rite?
Yeah, that's a very good question. So actually, people can purchase a TAC scanner. So we're selling TAC 7 scanners since July 1st. So we already installed quite a few devices. So right now we're installing almost one device per week. So yes, you can purchase them. If you want to have more information about that, we will share you some possibilities to contact us later on after the questions and answer session. And of course, we also have a scanning service. So if people really want to get material scans, we can offer the scanning service, and this is something we do currently out of our Grand Rapids office in the U.S.
Excellent. Our next question is for Mike with Autodesk. Mike, what version of Autodesk VRED is compatible with TAC?
Okay, so it's not just a release version, it's also the level of license as well. So to read in the AXF format, you need to have VRED Professional. And then we've been supporting it since 2016 and obviously future releases as well. Once it's been read in and worked with a professional license, it can be and saved to the VRED materials database. It can then be used with Fred Design as well, but you need the Fred Pro license to start with, and then from 2016 onwards.
Thanks, Mike. Our next question is for Mark. Mark, are spectral power distribution data taken into account when rendering color?
This is related a little bit to the first question. In the rendering of the AXF files, we provide the linear RGB in the internal format. So this really depends on how the rendering system manages that. In our OpenGL, we take into account only the RGB values, but the spectral power distribution response of the material is captured in the initial processing of the AXF file, and the color is accurate from there. But at this point, the support for spectral AXF is planned, and that will depend on the compatibility of that with other rendering applications.
Thank you. Our next question from the audience is for Toby. Can Total Appearance Capture output image files and or materials compatible with commercially available real-time 3D engines such as Unreal and Unity?
Well, gaming engines are clearly something we are looking into, and there's a lot of people integrating the AXF format right now. So the ones who are supporting AXF is, for instance, Autodesk, as we learned today, with the free VRED application. Also, NVIDIA Iray is supporting AXF. Keyshot is supporting AXF in version 6.2. Lumiscaf has already announced that they are working on AXF support. And there is a bunch of more companies implementing the AXF format right now. So I can't speak too much about that because we're under NDA with those companies implementing the AXF format. But it's gaining really popularity, and I can assure you that gaming engines are clearly something which is very high on our radar.
Great, thanks, Toby. Our next question is for Mark. Why do we have material type to process scanned material? Shouldn't all appearance properties be automatically determined by the scan?
Yes, good question. The big issue here is just there's actually two factors that go into this. One is that right now we've really invested in trying to produce the best output, which means that for this material output, we have defined a particular model which supports that, and also the parameters that go along with it. This output, even though it is pretty unique, so for example, the difference between car paint and a textile is something that can be determined, we haven't put the smarts, the AI, into the system yet to be able to tell the difference between the two prior to the measurement process. So there's a bit of that goes in just a discovery process that is aside from the actual measurement process. We found that a user is able to provide intelligence into the system to speed the process up. And that essentially works into the second reason, which is that if we know certain characteristics of the material ahead of time, then we can make assumptions about what information needs to be gathered and how much time we need to take in that processing. And then that produces a much more efficient output for our customers. This could all be done automatically, and I suppose at some point that will happen, but that is not implemented yet.
Thanks, Mark. Our next question from the audience is for Toby. Can your system handle translucent materials?
Well, translucency and transparency is something which is not handled currently by the system. So what we do is really the kind of setup in the device is quite modular. So it's like when you look at the TAC7 device, there's a big hole in the center, and we start to do things underneath the material to capture such thing as translucency and transparency. At the beginning, what we will do is we will add a module which allows us to create an alpha map. So this is really something very simple to get an idea on transparency. So this is something where you can identify meshes, for instance. Is material present or is it not present? But then there is more things we have in mind with this kind of system. But it's not really decided yet how this solution will look like. So stay tuned for that. It's certainly something which will be something we're looking at next year. And there's also the possibility to look at other sources like the formulation system. So if you have a material like plastics, certainly such information could also come from different sources which are not a direct scanner, which is a formulation-based technique.
Thanks, Toby. Another question for you here as well. Can you please elaborate on what parameters of measured materials will be editable in the future?
What will be editable in the future? So what you can do is basically we're storing maps. So we're giving you a normal map, for instance. This kind of information is already something we can edit outside the application. So you can export these things to other applications. That could be Photoshop, for instance, if you're more in this kind of traditional image workflow. And we can re-import this data into a Pantora application again. Well, then there's other things which we're trying to edit. So for instance, you can already edit in Pantora the diffuse color. So we can extract the diffuse color from the appearance file, and then you can start to edit the color. Of course, you can also edit the texture. So this is something also we can do right now. And there will be other editing possibilities with instruments in the future. So right now you can tune the LAB values, for instance, but there is no reason why you couldn't use an instrument for doing this kind of edits.
Mark. Thanks. Next question is for Mark. Does it capture volumetric flake inside a material?
Yes, well, that's kind of a loaded question there. So the answer to that is yes and no. Yes, in that it captures the effect of the volumetric flake inside the material, and no, it doesn't actually know that there is a flake there. So the information related to formulation, for example, of a car paint is not really available, and so is not editable as far as, for example, you can't change the density of your flakes to make it more sparkly or change the orientation or anything like that. What is captured is a very high precision reflectance map in a hybrid BTF type of model, which allows the lifetime of the reflection of each of the flakes to be captured and then reproduced in a way that is indicative or is a good representation of how the material actually behaves under those lighting conditions. And so the car paint implementation and the model that we use is considered the most advanced and is really a spectacular implementation of what car paint actually looks like. And this, at some point, I suppose, if the technology advances quite a bit, we'll be able to extract formulation parameters. But at this point, it is a visual representation of the flakes as opposed to a an actual physical model of them.
Excellent. Thank you, Mark. Looks like we have enough time for 2 more questions from the audience. Our next question is for Toby. Is the virtual light booth included with Pantora? And can you talk to the whole system, what is included?
Well, okay, so what we have is the TAC7 scanner. So this is really the scanner device. So this is the hardware. Typically, this comes with 3 Pantora licenses. So you can, it's a floating license, so you can run it on as many computers as you want, or you can install it on as many computers as you want, but you can only run 3 licenses in parallel. And this is really what we think is making a lot of sense with one TAC7 scanner. TAC7 scanner itself, so this is the hardware. Then typically there is a maintenance contract which comes with the scanner. So we give you a year maintenance contract with it. Typically what we do with this maintenance contract is we check the device once a year. So you will get a visit from one of our service guys, and they will do preemptive maintenance once a year. So they will do the whole calibration, which we do during the setup. They will redo that after a year. They typically open the device, they clean all the components, they replace some of those components which need to be recalibrated in the factory. So this is typically the spectrophotometer inside of the device. This is something we do on a yearly basis. With the software licenses, you also get the updates during the first year, and then you have to renew the software licenses. So this is a separate thing for the Pantora software. The virtual light booth itself you saw today is not a product which we are currently selling, so this is something which is still under development. I expect here that we will start to market that early next year. So stay tuned for the virtual light booth. Though we've shown that to customers, or we've shown prototypes at different occasions. So we showed it at different trade shows already. So there is a chance to see that. So recently we had it at SIGGRAPH. But we're also still intending to show it at different occasions throughout the year. So this is really what comes with the software. The software itself, you can also purchase Pantora separately. So there is different flavors of it. So just contact us, and we can give you some details, and we will provide you contact information after the question and answer session.
Excellent, thank you. We have time for one more question here, and also just to kind of build off of that, if you want some immediate information, certainly check out the link that's on the screen right now for more information on TAC. Our final question is for Mark. In wood substrates, is it possible to stain or paint parts virtually?
Well, unfortunately, at this point, this is a scanning type of system. So what we're doing is we're extracting information about the current scan that we have, which includes color and texture and variation related to that. So in a formulation system, you would be able to do that, and we have some other software which X-Rite works on and produces that actually would manage that process. But in this one, this is mostly for taking measured samples and making sure that they are being reproduced accurately. So it's really out of the scope of what this software is aimed for.
Great, thanks, Mark. Thank you, Toby, Mark, and Mike from Autodesk. We certainly appreciate your time today in the presentation. We've reached the end of our time. We'd like to thank our audience for attending this live webinar event. Please click the link on your screen for further information about X-Rite's Total Appearance Capture solution. If you're interested and would like to reach out to us directly with more information, just leave your name and best contact method in the Q&A box to your left. This concludes today's conference. An on-demand version of this webinar will be available at xrite.com in the next few days. Thanks for participating. You may now disconnect.